Hello, today let's look at one type of questions of critical reasoning, reasonably tricky, something does mix in a little bit of reasoning or some bit of quantitative touch to it, which is the number percentage problems in critical reasoning. One example that will set it straight as to what I am talking about is what we'll consider so that we know what is the question type. Example number 1. From 1973 to 1989, total energy use in this country increased less than 10%. However, the use of electrical energy in this country during the same period grew by more than 50%, as did the gross national product, the total value of all goods and services produced in the nation. If the statements above are true, then which one of the following must be true? Let's look at it. This does somewhere faintly seem like one of those questions where we can go ahead and weaken the argument. I say that my total expense last year increased less than 10%, but my expense on movies increased 50%. How is this possible? Wherein I say that my total expense has increased my expense on movies has increased 50%, total expense has increased only 10%. Probably a thought process says that my expense on movies was not a substantial amount. Probably. Let's look at the options to understand what could be the thought process. The first option, most of the energy used in this country in 1989, the moment I reach here, I'll just dismiss the option because it's talking about a specific year. Whereas here we are considering the range from 1973 to 89. Even if it makes sense, I'll probably dismiss the option even without looking at it. As the first option goes by, I'm tempted to check whether are there other options along the similar lines. And when I look at it, option D and option E both are talking about one particular year. Straight case of a rejection, out. Now we are left with two options, B and C. B says from 73 to 89 there was a decline in the use of energy other than electrical energy. Electrical energy increased by 50%, others had a decline. I might not be able to justify how does the overall increase is only 10%, it should have been more, or probably we don't know. We are not able to justify the conclusion using the option B. If I talk about option C, from 73 to 89, there was an increase in the proportion of energy used in that country that consisted of electrical energy use. There was increase in the proportion of energy. This we can safely say. Say for example, we consider anything. If we consider, say probably 50 units as electrical energy, it increased by 50%, we are going to reach 75. What if we consider the total to be something like 100? That's only increasing 10, because that is increasing 10, this is increasing 50 by a base. If we consider the ratio, the numerator would be far greater. That means the ratio is increasing. It's a very safe statement to be made. It actually helps us stand by the conclusion which has been made. Such problems are called number percentage problems, where superficially we look at it, one cursory look will tell you that probably there's some other problem. A number has increased but still the percentage has fallen. But these are the kind of problems that are very standard. This is number percentage. Let's consider one more example, we'll be far clearer. The number of North American children who are obese, that is, who have more body fat than do 85% of North American children their age, is steadily increasing according to 4 major studies conducted over the past 15 years. If the finding reported above is correct, it can be properly concluded that, what is the question? That the number of children who are obese is increasing. Obesity here is defined as people who have body fat more than 85% of the people. That means here we are talking about a share of a pie. Let's consider options. Probably we'll try to reach something. The first one says when 4 major studies all produce similar results, those studies must be accurate. A very stupid conclusion, does not help us anyways. Option A, wasted. B, North American children have been progressively less physically active. So what? Again, this does not help me substantiate the conclusion. This is out. What are we looking forward to? We are looking forward to is that how is the number increasing? If the finding is correct and the number of people is steadily increasing, we have to justify that. If given the third data, the number of North American children who are not obese increased over the past 15 years. This is making me think, because we consider a pie, 85% of the pie is not obese, 15% of the pie is obese. Those 15%, what is written? That the number of North American children who are not obese increased. That means the 85% has increased. We all know one thing for a standard, that if 85% of a pie, the value is increasing and still the pie is 85%, that means that 15% is also increasing. So if that 85% of the pie is increasing, 15% is also increasing. So those who are not obese is increasing. That also means the ones who are obese is also increasing. This helps us resolve the dilemma we are into. This helps us resolve the question on number and percentages. Still, we will not conclude with we have looked at the other options. Option D, over the past 15 years, the number of North American children who are underweight has declined. Still does not help us conclude. Option D, not consequential. Option E, the incidence of obesity in North American children tends to increase as the children grow older. Age, there is no correlation given in the paragraph. Safe elimination of the option E. A smart question where good chances that we would have eliminated C also, because it's a thought process based question. Here the pie, size of the pie is increasing, so every share of the pie will increase. That helps us conclude the option C as the right answer. Generally in number and percentage based questions, they'll play around with either giving a number and say this number is increasing by so and so, what would be some implications of what would be the change in percentage. On the other hand, sometimes they'll give you percentage multiplications and ask you what is the implication on the numbers. If you're just about careful in the way you approach the conclusions, these questions become easy. Best of luck.